Well, let's talk about 9.5. 9.5 is called logarithmic functions. And this is where they will introduce you to something called a log. And we know that we saw that if we have an exponential function, it's 1 to 1. And so it has an inverse, doesn't it? And we know how to find the inverse. We know that we switch x and y. So let's do that. And then we solve for y. But look, what would you do next to solve for y? You're kind of stuck. There's no way to pull that variable out of the exponent. And that is what a log is for. Logs pull exponents down. And so if you see something like this, if you see that y equals the log, we'll call the base b of x, that means, or it is equivalent to, x equals the base raised to y. So y, what the log is equal to, is from the exponent. The base of the log is the base of the exponent. And what you're taking the log of is out right here all alone. So this is pretty important right there. That's what you want to understand, and be able to go back and forth with easily. So the first thing that the homework asks you to do is it just says to write something as exponential. And it's going to give you a log. So if I said that the log base 7 of 49 is 2, and I want you to write it as an exponential, I'm giving you a log, and I want it to look like this. So remember that the base of the log is now the base of the exponent. So that 7 becomes my base. And then the exponent, right here, what the log is equal to becomes the exponent. So right here, the log is equal to 2, and that's going to become the exponent. Now what that's equal to is what you see right here. So in other words, if you look at this, when you have the log term right here, this x right here is all alone right here. So that equals 49. And you can see that, yes, that's true, and that's good. So at first they're kind of nice, and they'll make sense, and that makes it easier to know that you're correct. How about, what if I said the log of base 8 of 1/8 is -1? Now, if I were in my class, I would say, what's my base? And I would wait until someone figured out the base of the log is the base of the exponent, so 8. And then I would say, what's the exponent? And I would wait until someone figured out that this, what it's equal to, is the exponent. So I have 8 to the -1 equals, what does it equal? Well, whatever's right here, or in other words, right here. I guess this and this are flip-flops, so that could be throwing you. I should probably write it like this: log base b of x equals y. So that, this and this are equivalent, but this looks like this. So it might help you a little bit. So equals 1/8. Alright, let's do another one. How about if I said the log, I can't read my base, log base 3 of the cube root of 3 is 1/2. Alright, in your minds you should know now, the base is the base of the log, the exponent is what it's equal to, and the answer is what you're taking the log of, so root 3. And look, we know that an exponent to the 1/2 is the same as the square root, so we're good. Alright, now they could just throw variables in, like they could say log base 12 of x is b, and then you can't check it as easily, but you should know by now that 12 is our base, b is our exponent, and our answer is x. So they'll just have you practice that a few times. And in this section, that's all you're going to do. It's in the next section that you have to use that to solve equations. So now let's go the other way. So now they want you to write it as a logarithmic. So they're going to give you an exponent, And you could check that. You know 3 times 3 is 9, times 3 is 27, times 3 is, in fact, 81. So that's just a basic log that we know is true. But if they want you to write it as a logarithmic, I'm sorry, it's a basic exponent that we know is true. If they want you to write it as a logarithmic, first of all, you know you need to write the word log. So log. And the base of my log is the base of my exponent. And this, by the way, is like a subscript. It's not down lower. It's on the same line, but it's smaller. It's a subscript. So I have log base 3. And what do I take the log base 3 of? What it equals. 81 equals, and they're equal to the exponent. And that's the whole point of a log. A log allows you to get an exponent alone. So that's why they're so powerful. So my 4 is now all alone. Let's try another one. How about 2 to the negative 3 equals 1/8. So, again, I know I write the word log to begin with. The base of my log is the base of my exponent. So I have log base 2 of, and that is what it's equal to. So I have log base 2 of 1/8 is equal to the exponent. Remember, the exponent is now all alone. Alright, then what they ask you to do, they just take that a step further and say find the value. So they don't write an equal sign for you like they did up here. They're just going to say, if I gave you log base 2 of 8, what does that equal? And so it's not written, but you can think in your head, okay, what does it equal? And then convert it. When we did that up here, we're going to convert it so our base is the base of the log. Our exponent is what it's equal to, so we don't know that. And it equals what you're taking the log of, so it equals 8. And then I just have to go, okay, 2 to the what is 8? 2 times 2 is 4, times 2 is 8. So I need 3 of them to equal 8. So it's 2 to the 3rd. And so that is the value. Log base 2, oops, I'm off the paper. Log base 2 of 8 is 3. Okay. How about, let's do another one. Let's find the value of log base 3 of 1/9. So again, I'm just going to think in my head, what does that equal? And then convert it to exponential. So the base is 3. The exponent is what we're finding. And we know it has to equal 1/9. Now you'll see a lot of these. They like these because you know that there's a way to make 3 equal 9. 3 to the what would be 9? And you're probably saying 3 squared. So if I want to move it to the bottom, how can I move it to the bottom? That's when, remember, that you use negatives. If I have 3 to the negative 2, I make that positive by putting it on the bottom, and now it's positive 2. And that equals 1/9. So the question mark is that negative 2. That negative 2 is my answer. Here the answer was 3. Here the answer is negative 2. Alright, out of room on that paper. Alright, now they could ask you to solve and get you familiar with these logs a little bit. So if I wanted you to solve something like this, log base 2 of x equals 4. And they're pretty nice. These are kind of made to fit nicely and neatly and kind of work, and we'll see harder ones in the next section. But right now, to find what x is, we're going to use that technique we just used and convert this to exponential. So once again, the base of my log is the base of my exponent. What the log is equal to is the exponent. And so 2 to the 4 equals what you're taking the log of. So 2 to the 4 equals x. So we know 2 to the 4 is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, right? So I have x equals 16. And that is the answer. That's you're done. How about this one? Log base x of 9 equals 2. And if I were you, I would pause your video and try and do this one. And then let's do it together. So, once again, the base of my log is the base of my exponent. My exponent is what the log is equal to, so x squared equals, and that equals what I'm taking the log of, so 9. And so to make this true, what do you need to square to equal 9? And you all know it is 3. Alright, how about this one? I've got 2 more we want to fit in here. So, if I gave you the log base 7 of 1/7 equals x, could you solve for x? Okay, once again we take the base of the log, 7, equal, or base raised to, our exponent is what the log is equal to, so it's raised to x, equals, and our answer is what we're taking the log of, so it's 1/7. And so, how do I just take a 7 and put it on the bottom? Well, if I raise it to the -1, we know that we make it positive by putting it on the bottom. So that is what x equals. X is that -1. Alright, last one. How about this one? Log base 2 of 1 equals x. Alright, so now again, the base of my log is 2. The log is all equal to the x, so the x is the exponent. And this is equal to what you're taking the log of, which is 1. Alright, now how do I change 2 into 1? What would I need to raise that to? 2 to the power of what equals 1? Well, hopefully you remember from exponential equations that if that is 0, it equals 1. So that is your answer, 0. X needs to be, if I have 2 to the 0, that is 1. There's my check. Now, there's a few little rules that you want to be familiar with before the next section. And the first one is what we just did right here. If you have the log of anything and it's going to be 1 right there, then you know that it will always be 0. Okay? So, let's actually write it like this. Log base b, so we'll call b our base for anything. If that's a 1, it equals 0. That's kind of a yucky way. Let's write it like that. Log base b of 1 equals 0. Another thing, if I ask you to simplify this, log base 6 of 6 to the 3rd. Now, if these are the same, look what happens. Again, let's just imagine we're figuring out what it equals. So I have base 6 raised to the exponent, which is what we don't know, and it has to equal 6 to the 3. Whatever's right here is what it's equal to. So for those to be equal, we know that the question mark has to be 3, doesn't it? And so that's your next power. Your next rule, says log base b of b to the x equals x. So just like we saw right here, if this is 6 and this is 6, then this and this are also the same. So those are the same and those are the same. And the last rule that we want to be familiar with is if we were going the other way, if I had 7 log base 7 of 5, and I wanted you, let's convert that. This is an exponential because, believe it or not, this is a base and this is an exponent. So if I wanted to convert this to a log, I would say log, I would write the word log first. The base of my exponent is the base of my log, and what it equals is what you're taking the log of. So that's what we don't know. So log base 7 of whatever it equals has to be the exponent. So all I'm doing is converting exponential to log. So you can look back at that if you need to. But I've got base of the log is the base of the exponent is the base of the log, and what it equals is what you're taking the log of. And now I'm going to say equals the whole exponent. Remember that the whole exponent is what's alone. So once again, for those to be equivalent, what does the question mark have to be? Well, it has to be 5, doesn't it? Then they would both be log base 7 of 5. And that would be true. Log base 7 of 5 equals log base 7 of 5. So that's your third kind of rule we'll write down. If you have base b and you're taking the log of that same base of something else, they will also be the same. So those will be the same if those are the same. So that will kind of help you in your simplifying logs if you kind of keep those 3 rules in mind. And if you forget them, you can just figure them out, just work them all out like we did, but they might come in handy to know. Let's see. Oh, there's some more. Okay, another thing we need to do in this section is we need to graph a log. So once again, we're still in 9.5 and we need to graph a log. So if I wanted you to graph, let's graph y equals log base 4 of x. Well, since we can't plug it, we don't know how to find log base 4 of any number yet on our calculator. So what we're going to do is we're going to convert it to exponential. So if I were going to convert to exponential, we know, we did this before today, that our base is 4. So the base is 4, and the power is what it's equal to. So I have 4 to the y equals what you're taking the log of, so x. So that we can do. We can handle that. So let's use that and make an xy table and graph it. Okay. So plugging that in, now we're going to plug in y instead of x because y is in our equation. So if I plug in 0 for y, so if I plug in 0 right there, I have 4 to the 0. So if I have 4 to the 0, maybe I'll write that over here, we know that anything raised to the 0 power equals 1. So our x is 1. Now let's go ahead and plug in 1. So if I have 4 to the first power, that equals 4, doesn't it? So our x value right here, if I put 1 right here, x is 4. Now, let's go ahead and graph those just so we know what we're looking like. We've got over 1, up 0. Now, that's an important point because you remember before when we graphed exponential functions, we always have the point over 0, up 1, don't we? So remember that these are inverses, logs are inverses of exponents. So if we folded y equals x, that point would be right there. So with a log, you're always going to have this point. So if this is my origin, we'll put a box there. I've always got right 1. Okay? So from our origin, we go right 1. Then, look what happens here. If I go over 4, 1, 2, 3, 4, I go up 1. So I've got this point right here. Let's keep going. Let's go the other way. Let's put in negative 1 for y. So if I put in negative 1 for y, then I know that I have to make that positive by putting it on the bottom. So x equals 1/4. So now if I go negative 1, let's see. If my x, I'm going to go over 1/4, and then I'm going to go down 1. So I'm right there, over 1/4 and down 1. So look what happens. This graph looks like this. And just like exponential functions get closer and closer to the x-axis but never cross it, logarithmic functions get closer and closer to the y-axis but never cross it. So wherever your origin is, you have an asymptote, and we'll draw it with a dotted line, and in this case it goes right through the x-axis at 0. So that's how we graph logs. But I don't want you every single time to have to convert it to exponential and draw a table and plot points. So we're going to make some rules up. Here's the rules that we're going to use. If I want to graph a log, I know that every single time I go right 1 from your origin. Now, just like exponential functions, you can shift your origin. So your box might be up or over. However, I think that in 1010, in 1000, they're pretty nice and they don't shift your logs yet. So we'll always go right 1 from our origin. And if it's shifted, go from your shifted origin. Then, here's your secret. If you go up 1, you're always going to go, look, when we went up 1, where's our up 1? Here's our up 1. We went over the base, didn't we? So when we went up 1, we went over 1, 2, 3, 4. which was the base of our log. So that's your second rule. If you go up 1 from your box, wherever your box is, up 1, you go right the base, or over the base, whatever the base is. So in this case, 4. If you go down 1, what did we do? We went down 1. Look, we did 1/4, which is the inverse of the base. So if I go down 1, I go right the inverse of the base. Okay, so now we don't have to convert to exponential, plot points. We can just use those 3 rules and graph. So, for example, if I wanted you to graph f of x equals log base 3 of x. I know there's no shifts here. I'm not adding anything. And shifts would look like this. If I had a shift, it might look like this. Log base 3, I could see x plus 1 in parentheses, or I could see x plus something out there, or subtract. But guess what? They're pretty nice, and they don't give you any shifts. So you don't have to take care of any shifts, but you just have to know that your origin is here, and from my origin, I go right 1 every single time. Memorize, right 1. Then, if I go up 1, I go over the base. 1, 2, 3. Then, if I go down 1 from my origin, I go the inverse of the base. So what's the inverse of 3? 1/3. So I'm just going to go over 1/3 right there. And then remember that there's an asymptote through your box, through your origin every time, and you're going to get closer and closer and closer to that dotted line and never cross it. That is the graph of a log. So send me questions if you have them, and good luck on your first taste of logs.